All right, and it is recording, so it looks like it's working. Okay. Yes. Does anyone else need one? Okay, so today we're doing hyperbolas. We're going to do a whole bunch of stuff with hyperbolas. Okay, here we go. So, hyperbolas. So these are another, the way that, I haven't told any of the class today, I'm talking about conic sections and why they're called conic sections. I haven't really shown you anything about conic sections, right? Or how the shapes, which parts of the cone each shape is. But the hyperbola is actually formed by taking two cones, stacking them point to point, and then slicing vertically down, right? That's how you get the shape of the hyperbola. So if you look at the cross section, so if you take two cones, right, if you take a cone, and then another cone, right, and then say you slice vertically down, it's the shape that you would see if you were to look at the sideways. So it's this shape that you would see, right? That you would see if you were to look at that cross section, right? So. Okay, good. I hope I confused you well. What I need to do is I will try to pull up some images of some conic sections so you can see it better. But anyway, that's how it's called. They're called conic sections. Do you guys know that these are parts of the cone?
Yeah.
Yes. Oh. Okay. All right. So there you go. Yes. Circles, right, parallel to base, right? You cross section. Parabola is actually parallel to the slant of the cone, and then an ellipse is like a skew. How do you say not? Side slanty that's not parallel.
If it was.
Yeah. So anyway, okay. So here we go. We've got hyperbola. The only thing I want you to know about the equation of a hyperbola is, number one, there's a minus in the middle, right? Ellipse, there's a plus in the middle. Hyperbola, there's a minus. The letter that comes first tells you which way it's oriented. So if the x comes first, it's a horizontal hyperbola. If the y comes first, it's a can't do it. Vertical hyperbola. Woo, that's a mind thing. Okay. Woo. Okay.
Not really.
Yeah.
I think it's just you.
Okay.
Kind of legend.
All right. Vertical hyperbola. Center is the same. The number under the x tells you how far left, right. The number under the y still tells you how far up and down.
Brilliant.
The only, yes?
So the way like that a hyperbola changes, is that similar to the way like just a parabola changes like at the same rate?
No.
Okay.
But I couldn't explain to you with any authority what the difference is.
Okay.
I just know they're not the same. Okay. Okay. The foci of the hyperbola, this is the other difference between ellipses. Ellipses, it's c squared equals a squared minus b squared. You subtract. For hyperbolas, you add. So I kind of like to think that both of the signs change, right? So in ellipse, you have a plus here and a minus with your c. And then with hyperbola, you have a minus here and a plus with your c. So, anyway. All right. And it's easiest for me to teach you if we just walk through an example. So here we go, walking through. First example, what's the center?
-3, 2.
-3, 2, right? Center is the same for all these problems. So the first thing I always do is plot the center. -3, 2, there's our center. The number under the x tells you how far left or right to go. So we're going to, from the center, we're going to go out 2 in each direction. So we go left 2, right 2. The number under the y tells you how far up or down to go. So we're going to go up 3, down 3. From there, the way that I do it is I make a little box. You don't have to draw the box, but I do. That's just an old habit. So I draw a little box that goes through my vertices and my co-vertices. Why do I draw the little box? Because the asymptotes are drawn by connecting the corners of the little box. So if I go, there's my asymptotes. So now to sketch the hyperbola, I just go to the vertices and follow the asymptotes. Will this be horizontal or vertical?
Vertical. No, horizontal.
X comes through.
Why is it horizontal?
X.
Because X comes first, right? So I know then these are my vertices, and I just follow the asymptotes. Okay? You used to draw the box?
Yeah.
Oh, good. Okay. So the vertices would be -5, 2, and -1, 2. To find the foci, we need to find C. C squared is going to be 4 plus 9, right? So C is plus or minus root 13. So when we draw the foci, C is the distance from the center to each focus, right? So we go from the center out root 13, which is like 3.5. So we go 1, 2, 3.5, so we're about here. 1, 2, 3.5, so we're about there. So there's our foci. And then to actually write the coordinates for the foci, so these, I take my x, it's -3, and I add and subtract root 13. So my foci would be -3 plus or minus root 13, and then the y value is still just 2. Asymptotes. When you write the equations of the asymptotes, just keep them in point-slope form. The center is always on both asymptotes. So that's your point, right? So our point is -3, 2. So for our asymptotes, we're going to have y minus 2 equals something times x plus 3. Now we need the slope. So I just go from the center to the corner of the little box. So I went up 3 over 2. My slope is 3/2. Up 3, back 2. My slope is -3/2. The slopes will always be equal with opposite signs. So you can just put plus or minus 3/2 for your slope. And then you have both equations, right? Does that make sense? Okay, good. So, for the next one, before we start, what are you going to have to do first?
Divide by 8.
You're going to have to divide everything by 8, right? Reduce the fractions. So go ahead and try number 16. On your own, see how you do. I'm going to erase it. And I'll leave 15 up in case you want to look at it.
No comment.
same number below the x's and the y's, does that make it not hyperbolic?
Nope.
Still a hyperbola, right? Yeah. It's not like an ellipse where it becomes a circle, it's still a hyperbola. All right, so our center is where?
5, 1.
5, 1. Make sure you put the x first. Don't get tripped up that they wrote the y first, right? Okay, so our center is actually over here at 5, 1. We go 2 left and right, and 2 up and down to get a nice little square. And then we connect corners. Is this going to be a horizontal hyperbola or a vertical hyperbola?
Vertical.
How do you know?
Because y is squared.
Because y comes first. So you end up with
What?
that,
Yeah, that's a good question.
and you get that. Okay, so our vertices then will be 5, 3, and 5, -1. Okay, our foci, so we have c squared equals 4 plus 4, which is 8. So c is plus or minus root 8, which is plus or minus 2 root 2. So root 8 is a little bit less than 3, right? Plus root 9, 1, 2, 3. There, 1, 2, 3. There. And our foci then would be 5 and then 1 plus or minus 2 root 2. All right, asymptotes. So our xy 5, 1. So we have y minus 1 equals, they all will slope from plus or minus 1. So plus or minus 1 times x minus 5. Any questions on any of this? Yes, Shreyas?
With hyperbolas, you know the thing you said if you shoot a light, it'll always hit the foci. Is that similar for hyperbolas or no?
I don't know. I don't know any good stories about
Because
hyperbolas.
you said
Well,
that
but
they
it-
don't change the same as parabolas, so I don't know if that really.
No, but it's.
But they have a different foci.
No, but if you think about the conic function, I mean, wouldn't the hyperbola literally just be 2 parabolas? Like if you get a cone, because a parabola is
But
just
they're
that
not
same-
parabolas.
But a parabola is that same kind of cross section taken out of a single
It
cone.
looks like it, but they're not parabolic. You don't have that, I don't think you have that same.
No, but we have a different foci.
Yeah.
Defines the foci
Okay,
too,
okay,
so
but
it
his
should
point
work.
is that you just told us that the cross section of the cone is a parabola, and this is just
A
two.
no, a parabola is not, it has to be it's a cross section that's parallel to the slant.
Oh, right, and then the other
Right.
one, what was the one that was?
So,
The ellipse was the one that was not.
right, an ellipse is one that's gonna be like an oblique or whatever you call it, skew cross section, right? A hyperbola has to be a vertical cross section, so they're slightly different. And I'm pretty sure, I'm 93% sure that
She's an A.
if you call this P, this is not 2P in each direction. So the property of the focus is not the same, but I would have to look up
No,
to
it would be
see.
though. There's no point in labeling it.
I
What if
will
it's-
check for you, but right now I can't, but I will check for you, okay?
What if what it is it's almost like a reverse, so like if you speak, if you're standing at the center and like you speak into it, it'd be
Okay,
like
we
almost
have
like
to move
directly
on.
sideways.
I so appreciate your
Hypothetical.
curiosity, yes, but we have to move on, okay? And then we will go back. I will answer that question, but we gotta move on. So. Thank you. That was the word I was looking for, was curiosity. I just couldn't get it. So, which is funny because we just read Curious George last night. So anyway, okay, so for this type of a problem, you have 2 squared terms. You have an x squared and a y squared. You need to complete the square. When you complete the square, put the one that's positive first and the one that has a negative leading coefficient second, right? I want everyone to take a second and just see if you can get the completing the square part of this done.
This price, why is 17 and 18 the same thing?
Because we wanted to really emphasize that concept. for these exact numbers. They're really important.
They're just twins.
I know.
This is a hint that it's.
You meant to print one, but the inverse.
Yes, this problem is on the
I
test.
wish I didn't
Yes.
speak here.
That's gonna be easy.
This is the test, right here.
Wait,
This
oh,
packet.
This packet.
You got it.
so if we complete this packet, we can have 100 test points.
Alright, so anyway, I'm pretty darn sure that none of this is on your test, that you're, because the reason that we're learning this is we're going to use polar equations for conic sections, right? So we're gonna bridge this with parametric and polar.
That actually makes me very sad because I like this unit
I know.
so far.
That's because it's just algebra 2.
Wait, really?
Yeah.
Alright.
Okay. Alright, so, moving on. So, anyway, so you put the y's together, you put the x's together, you had to factor out a -4 in order to complete the square on the x's. Remember, this is not a one-sided, it's a two-sided. So if I add 1, I add 1. If I subtract 16, I subtract 16, right? So you end up with y minus 1 squared minus 4 times x plus 2 squared equals 4, and then you have to divide the 4 because you have to have a 1 there. Does that make sense? Am I going too fast or are we okay? All right, I know we only have a minute left. Okay. After that, it's all just everything that we've done so far. Nothing is different. So your center is at -2, 1. Plot the center. Then you're going to go up 1, down, let's see, left 1, right 1 from the center, and then up 2, down 2 from the center for your y's. Make your little box, draw your asymptotes, sketch the hyperbola, center, vertices, foci, asymptotes. I wish we had time to do one more. I'm going to probably just
I actually need to go.
cut off the tape here. I think you guys are okay. Okay. All right, good. So, have a great afternoon, and tomorrow we will do our last quiz.